Cool. Okay, welcome to this episode of the Operator View. I'm your host, Nick Swink, and this month we've got a very cool topic, which is a modern phishing technique known as device code phishing. Maybe you've heard about this, maybe you haven't. If you haven't, you're in for some good content. We got a few slides, some topics, and then we'll jump into some live demo. I got two different versions of the same technique, one for GitHub, one for Entra ID, and we will jump right into it. So basically we're going to talk about what device code authentication is in the OAuth spec, phishing using this device code flow and how it's abused by threat actors, why it bypasses MFA, and some of the realistic attack paths that have played out in the real world. And of course, we'll show some cool tooling and demos for everyone to view. All right. What is device code authorization, or the OAuth 2.0 device authorization grant? It's quite a mouthful. First, we'll say OAuth, which is, if you don't know, an industry standard for authorization, which is a framework that allows you to grant apps permissions to your account, either to access data or perform actions on behalf of your account without using your username and password. So most commonly, it's used with single sign-on. So if you've ever used your Gmail account to single sign into an app like Slack or some other third-party app, and you use Gmail to do it, and you didn't have to create a new account, then you've used OAuth authentication for single sign-on. Basically removes the process of the application holding the identity or being the identity provider for its own app. So you don't have to create a new account with username password every single time you sign up for a new application service. You can use, say, Gmail as the identity provider, which provides single sign-on access to the app, or Entra ID as the identity provider, or Okta, so on. So in OAuth, there's different types of grants, which are different authentication flows, and they each perform and are used for different scenarios. So there's like client credential flow, there's implicit grant flow, and device code flow, or the official terminology is device authorization grant, is its own specific type of OAuth flow. Now, it was first introduced, I believe, in 2019, and it was implemented for devices that don't have a easily accessible browser to enter credentials. So things like smart TVs or CLIs or IoT devices. So if you've probably also used this type of authorization grant. If you've ever signed into a streaming service on your television using your smartphone, so you sign into Netflix and it pops up with a link that says, it's a short link, and it says enter this code on another device to sign in, and you enter this code, and you're either already signed in on your phone or you have to complete that authentication, and then it will complete the device authorization grant and sign you into the TV, and you didn't have to enter your password with the TV remote, which is great, assuming that you have a long, complex password. So super useful for that type of scenario. And it basically works by, I have on the little graph here, the device asks the identity provider to start the flow. The identity provider returns a code and some other stuff. The user goes to the URL, enters the code, authenticates, the device polls for the successful authentication, and then they get an access token to the user account. Usually, the access token is in the form of JWT, or it could be some other type of token as well. So, how do people phish using this device code flow? So, again, this has been around for a long time, few years, probably 7 years at this point. Basically, an attacker can pretend to be a device and make those authentication calls to the device code endpoint, get a user code, and supply that to a victim, and use a pretext to get them to complete the device code authorization with that given code. The real problem relies in the identity provider doesn't have a way to distinguish whether the person that requested the code is the same person that is completing the authorization grant. And because of this, threat actors have used this to perform phishing attacks with it, in which they get a token for a valid access token, a refresh token for the victim account, without ever having to have them enter credentials. If the user's already pre-signed into an account with the MFA grant already labeled in their access token, then they can just basically click sign in, and it grants the attacker an access token to their account. So it's a pretty sneaky technique. It's been around for a long time. There hasn't been much done in terms of mitigations from the identity providers. We'll say Okta is pretty difficult to perform this attack against, if not impossible, because of the scopes or permissions that the device code grant gives to the access tokens. But you'll see in a bit, Entra ID and we'll say Entra ID gives quite the amount of permissions or scopes for an access token doing this type of authorization. Whereas GitHub basically gives the authorization or scopes requested, which makes sense. Okay. So talk a little bit about why it quote unquote bypasses MFA. It doesn't necessarily bypass MFA in the sense of completely exploits MFA and, it's not required. When we say it bypasses MFA, it means that the user is already logged in. So they had already performed MFA. And so it's not needed to be performed for this attack to be successful. They already have the MFA grant enabled in their signed in session. And so when a attacker exploits this authorization grant via phishing, they're given permissions as if they did perform the MFA, but it's just because the user was already logged in. And so there's also there's access tokens and refresh tokens that are accessible to the attacker with this technique. And so the access token gives you direct API access, and the refresh token is used to refresh access tokens until the refresh token expires. Usually it's lasts quite a bit longer. It can vary depending on the settings of the identity provider. And then there's the primary refresh token. This is for Entra ID specifically, and this is a refresh token that lives on the device. So it lives on the device and it grants access to a bunch of different applications within the Microsoft ecosystem without the need to re-authenticate, and it can usually lasts up to 90 days. So this can be a long-lived persistence if an attacker is able to register a fake device given certain permission scopes, and then get basically generate a primary refresh token. And so for detection purposes, there's a limited detection surface when it comes to this type of phishing because you're using the legitimate device code endpoint for Microsoft. You're basically just having the user enter a 6-digit or 8-digit alphanumeric code. And so there's not a lot in terms of detections other than maybe an abnormal sign-in via this specific OAuth grant type. But you have to be specifically looking for that type of thing. You can implement some conditional access policies that completely block this type of OAuth code flow or a device code flow. But depending on different things you have in the tenant, this could break functionality if you're using this code flow with, say, like internet connected phones or IoT devices. Okay, cool. So we're going to talk a bit about an attack path. So this is modeled after Storm 2372, which is an APT that Microsoft wrote a good article that they were observing this attack specifically being performed by this threat actor, where they would do exactly what we've been talking about. They would generate those device codes, send them via Teams or Signal, different messaging apps and stuff like that, and try to get the user to authenticate to legitimate Microsoft endpoints with the code. And then from there, they get Graph API access, and they can basically try to move laterally, do intra-org or business email compromise phishing to move to different accounts within the organization. It also highlights that they were using that register rogue device technique to escalate to a PRT, which is sort of the keys to the kingdom in terms of persistence. Basically allows you to persistently authenticate to Entra ID as a device that doesn't even need to be a real device. So that's the first attack path. This is definitely a realistic attack path performed by this threat actor and definitely many others at this point. Microsoft just released another good article, April 2026, about kind of a AI-driven version of this attack path, and basically highlights the advantages or advancements in tradecraft from this original Storm 2372 attacks. And then this one, I put theoretical, but to be honest, we've performed these in red team engagements, and other red teams have definitely performed similar things. I just don't have a public article documenting this in the wild, but basically using GitHub device code phishing, same as Entra, and then pivoting to internal private repositories and pulling out secrets in code, and then pivoting to other cloud resources like AWS or Entra or Azure. And so these are the two attack paths I'm going to demo. I'm basically going to use two VMs and demo both of these using some of the tools that are public and open source and pretty good tools. So for Entra, Graph Spy is by Redbyte Leet, and it's basically a GUI application where it sort of automates or makes it easier to use Entra access tokens to access different services in the Microsoft ecosystem, and gives you a nice GUI to do so. So accessing things like Outlook, Teams, OneDrive, SharePoint, and it's a really good post-exploitation toolkit. We also have Gitfish, which is a tool by Praetorian, which automates the process of device code phishing against GitHub. And it's more of a phishing toolkit instead of the post-exploitation stuff, which can be done pretty easily with the GitHub API and just like curl. So I think we're at the point where I can jump into some demos, which I will do now. So I've got two VMs here. One's the attacker Kali Linux, hacker machine, and the other is a Windows machine. And so first I'm going to show GraphSpy. Turn my Windows machine on because it likes to turn off. So switch back to GraphSpy. A little bit of lag. Okay, so basically, I'll show the GitHub repo real quick. So big shout out to this person, Redbyte Leet, and looks like pretty active development on this. And you can pretty easily install it on Kali with pipx install GraphSpy, and then it just launches up this local, I think it's a Flask app. So we'll serve it on localhost. And so you could see this nice graphical interface, and you could see some of the different services, Microsoft related services. Here we can see some things related to token manipulation. So we can import tokens, access tokens that we achieved some other way, or we can use device codes directly in the GUI here. So first, it will generate a device code based on the client ID, which is going to be basically the app, but it's a UUID. And I will just go with the default because depending on the client ID, it has certain scopes or permissions. And then here are some of the different device auth logins for Microsoft. I'll just go for this one, and I will generate the token here. And you could see it starts polling as if it were the smart TV or whatever. And it's only valid for 15 minutes, which is a notable restraint for this type of phishing technique. And here's the user code that you would deliver via phishing. So in this case, I'm not going to send an email or do anything crazy. I'm just going to go over here and go in the browser. So you can see that I'm logged into a Microsoft account, which most people are going to be logged into their Microsoft account if they're receiving this type of email. And you would have some phishing lure that would direct you to the legitimate device code endpoint here. So we could see everything looks legit, and it is legit. And there's no detections here other than if you had set some custom rules for this URL. And then we grab our user code, and we can just pretend in this case that it was provided via a phishing email. And we could see I'm already logged in. It may prompt me for, okay, password, okay, MFA. And this is because I'm not, this session was stale. Okay, you've been signed in. And at this point, it's already done. And we could see this turns green from the app here. And it's basically a valid, or this is just the response we could see. But if we go to tokens, we can see the access token provided here. And I'll skip past the whole token. And we can look at the scopes, which is most important part, which shows us some of the permissions that this access token has access to in the Entra Microsoft ecosystem. So it's pretty interesting stuff with maybe calendars not so interesting, but we can see directory read, files read, which is related to OneDrive. And we can see some others with user, read, basic, all. And so traditionally you would take this access token and you have to do the raw API calls yourself, but now red teams or good guys can just use the web interface here. So if we go to interact with OneDrive or recent files, you could see maybe didn't work here. Let's select the access token and refresh. We can see it is making those API calls in the backend using the access token that we were granted. So we can actually directly interact with OneDrive with the API, and we can see files backed up to the OneDrive, which in a lot of cases is replicating or synced to the desktop, downloads, documents, and other directories on their desktop. So if we kind of go into here, we can see specific files. We can go up. We can go into documents. We can see specific files. So you could see really quick how a simple phishing campaign can turn into legitimate access into an organization. We can download these files directly and open them up. See, looking for sensitive files, stuff like that. And this is just for the OneDrive, which is actually just SharePoint in the background. We should be able to interact with SharePoint, but we see we get no access because of permissions. So a little bit, and now we're getting more into the post-exploitation tradecraft. This isn't necessarily related to the device code phishing. But specifically in Entra, you could see they kind of break the OAuth model in that you can request different access tokens to different resources with the access token you have, which should only be scoped to what the scopes are. So we were trying to interact with SharePoint. We can select this one, which is a SharePoint client ID, and try to refresh. So you get a new access token, and then we could see this automatically sends that API request. So, and it's just going to show basically the user's SharePoint and some of the default SharePoint like directories, because this is just a test environment. So there's nothing legit in here. We can also look at Outlook, although we've just changed tokens. So I think if we try to get a different token here that's related to Outlook, I think maybe just the Microsoft Office, or we can go Outlook Mobile and select that latest token. And let's see. And we can reload and load in actual emails from the Graph API. So we can load emails and we can send new emails basically just using access tokens and refresh tokens. This way, in the Storm APT would send, secondary emails targeting people in the organization from already compromised email accounts. So very powerful stuff. There is a Teams API or page here to interact with that, but I haven't figured out, haven't gotten that to work yet, even with the valid Teams access token here. So I'm not 100% sure which client ID, or if Microsoft has changed something in the background. It's possible. So that is basically like a quick overview of GraphSpy and what could be accomplished with a simple device code phishing attack. And this is just using a default user. I also didn't touch on listing users and that sort of thing. So we can actually query basically the Graph API to pull down directory listings of users, look at different attributes for the user. And there's a bunch of built-in Graph API stuff. You can use stuff like road tools with access tokens to basically enumerate a bunch of stuff about a tenant and try to move laterally and escalate privileges within the tenant. So that's a quick overview of GraphSpy. We're going to pivot over to GitHub related tradecraft. So we will go over to Gitfish, which is a tool released by Praetorian. And I believe I was actually at the talk at DEF CON where this tool was released last year, I believe. It's a pretty awesome tool. There has been some mitigations applied by GitHub to limit some of the capabilities of the tool, which I'll talk about and show. But it essentially automates that device code authorization to GitHub and allows you to manage a phishing campaign to try to get basically initial access to GitHub accounts using just the API. So pretty cool. I'll hop into the tool here. So should be able to do Gitfish and start it. And it also has a nice web UI where it has different pages here for deployment, but originally the tool was designed for you would put your own or like a test user account GitHub token, and it would use that account to push a repository which had a landing page, and that landing page would be a GitHub pages, which would then display like a web page, and that would be the landing page. So it would be like a living off of trusted sites phishing page, basically. Although what I found was GitHub started shadow banning accounts that would, I don't know specifically what they were looking for, but at least with the built-in files that ship with this tool, they were blocking or they would shadow ban accounts that spun up this landing page. So that's kind of a hassle to deal with. And I figured it's easy enough to just host the landing page yourself somewhere else. It doesn't affect, you could still use the tool. You just don't use this deployment page. So it works very similar. And here we'll see the client ID, which is the app again. This is for, the default is for GitHub CLI, which has a good scope of permissions, and also that can be configured as well. It gives you a lot of access to different scopes within their GitHub account. And then you can change different things like the org name and stuff like that. And then you do need a email allow list for the tool to work properly and track users. So if we spin up the web server here, it just starts a secondary Flask application on 443. And we're going to do this all locally, but we do need a valid TLS certificate because of cores and the way that Gitfish works. So I will start an ngrok tunnel, which basically gives us a valid SSL certificate and valid HTTPS connection from the landing page. So this spins up this endpoint, which basically has an ingest point, and that just takes in a request from the front end, which will be this HTML page. This HTML page, because these codes are only valid for 15 minutes, you don't want to send an email, or if you're being the attacker, you don't want to send an email and it sit in the inbox for 15 minutes and then that code is no longer valid. And so even if the victim completes the phishing lure, you don't get access because the token's not valid for longer than 15 minutes. So what you do, or what the tool does, is basically this landing page queries the backend via JavaScript in the HTML, and then it generates a code in the backend, serves it to the front end. And so that way the code is generated right when the person looks at the page. So super cool, makes sense. We just have our URL to our actual Gitfish server here. So we have that spun up, and then I just want to host it here on a simple web page. And we do need to pass the email in the URL field so that Gitfish knows what user you're trying to target, basically. And so at this point, I think we can go to our victim, which I have in another page. So we've got this account. It's a test GitHub account, and it's got access to this saucy app. Okay, so this app is a private app, private repository, which means it's not publicly accessible. This could also be within an organization or something like that, whatever this GitHub user has access to. They could be a private repository. So in this demo, we're going to show how you can totally compromise this. It's important to note that the user's already signed in. So we'll suspend disbelief about this URL, and we'll just pretend that it's hosted on. It could be hosted on any website that you can control the JavaScript, the client-side JavaScript, and make CORS requests out. So in this case, we see, okay, this looks legit. What is this saying? Copy this code and complete single sign-on with GitHub. Now, this isn't very far off of what users are normally expecting. So if you get an email with a code that you're using to complete the single sign-on, this is a pretty typical thing to happen. And so this is why this phishing technique is very dangerous and very successful. So if we copy the code here and we go to the legitimate github.com with a login device, we can see this is all absolutely legitimate. We continue, we paste in the code here, we hit complete. We do get this nice warning from GitHub, which shows the IP address that the device code was initiated from, which in this case, it's a VPN. Don't try to hack me. And so, and then we get a list of the different scopes or permissions that this OAuth app or GitHub CLI in our case is requesting for the GitHub account. This part is needs a little bit more social engineering tact to it, whereas it can throw up alarms for the victims. And we'll just go ahead and authorize, and that's it. And now it's been done, and we can see if we go back to our tool here, we should see, well, some of these are from testing before, but if we go over to the console, we can see, okay, tokens captured for this guy, and they've been saved to here. And what it captured and saved is an OAuth token for the GitHub account. So I'm just going to grep it out here, or select it with JQ, and it should have copied the token into this variable token. And then what we can do with this token is anything that this scope had access to. So we could see the scopes here. So just notifications. Biggest thing would be like repos and workflow. I think we can also add new public keys to authenticate with. And we can interact directly with the GitHub API. So if we pass this token as a bearer token in the authorization header, we can directly interact with the GitHub API. I'll add JQ for some syntax highlighting. And we can see we now are authenticated to the GitHub API as a lab user. We can see different metadata about the user. I have some other copy and paste commands over here. We can look at the scopes of this access token using this user endpoint here. And if we go down to OAuth scopes, we can see the scopes here. Just another way to validate it. Also, if you found a GitHub token or PAT somewhere else, you could validate the scopes the same way. We can then look at repositories for the user. So these are going to look at the user's personal repositories. And we can see a bunch of data here. So we can actually see they only have one app, one repository here, Saucy app. Private is true. And we could see metadata about it. And then importantly, we can look at the clone URL. And what we can do is we can actually clone it. So we can do git clone. And then all you need to do is add the clone URL with the token appended at github.com. And you can actually authenticate and use the token. Real quick before that, I will show that you can look at orgs. So in most cases, users or victims that you're targeting for red team engagements will have access to an organization, and you would query the API for that and then look at what internal repositories they have access to. This case, they don't. This account is not a member of any. So we can go into that our Saucy app that we compromised, and we can see, oh, there's a .env file, and this is where you could use stuff like Trufflehog or different secret scanning applications to look at not just the code that's in the repositories, but commits, all historical commits, issues raised, anything like that, looking for secrets and API keys to pivot into other things. So we've got, AWS, this is just mock data, but we've got, different cloud services that you could then pivot to. So with a single click of the URL and then a copy and paste, your developers or you could get compromised, your GitHub account could get compromised. And I'm not really going to touch on the other things like you could do in GitHub with like workflows. So you could backdoor CI/CD pipelines in GitHub. If the user has runners that are on-prem, so self-hosted runners, they could basically, you could implement something into the CI/CD pipeline to execute code on a runner. There's a whole bunch of stuff you could do from there as an attacker. All right, thank you for watching, and we'll see you in the next one.